record. Hello guys, so we're going to cover the final review for Math 16A, which is like just a regular calculus. I'm planning to do this in a couple of sections, so let's start our first session by doing problem number 7. So for problem number 7, what do we have? We have like this following function, like x times e to the y is equal to blah, blah, blah. And we need to figure out what is our dy over dt. So whenever you do the problem, I strongly recommend you to think about, just try to remember. So first of all, you're going to have the cheat sheet on a final. Divide this cheat sheet in a way that all the formulas are going to be organized in and for each section, make sure like to name it and write down like all the formulas for like concepts, which are like the main one. And when you see the problem for the first time, this problem is usually going to come from a single section. So that's why you will need to use the formulas from that section. Here, what do I have? I see that I have x and y that depends of t, and that means that my formulas come to the related rates or like and the chain rule. I don't remember which section from the book that, but let's try to remember what are kind of useful information that. Okay, so let's see where to start. So first, well, I guess I'm seeing this problem for the first time. Take a couple of minutes, just try to think how will you approach this problem on your own. Meanwhile, I will just come up with an outline. I will explain it. Okay, so the first thing that you need to notice that for this problem, you have x as your function in terms of t, and you have y also your function in terms of t. Yeah, okay, x in terms of t and y in terms of t. So that means what I'm going to do, I'm going to do the implicit differentiation. And when you do the implicit differentiation, you do the implicit differentiation corresponding to some variable. In this case, I'm going to do the implicit differentiation corresponding to variable t, because you can see from this problem, from the context of this problem, that is like your intent. And I don't know exactly how it was explained, but I'm going to show you kind of the generalized idea how to do it. Here, the idea is that I'm going to apply my derivative corresponding to t to the whole expression. And this expression is going to be x times e to the y is equal to 2 minus ln of 2 plus ln of and remember, so what I'm going to do, I'm going to use the rules of implicit differentiation. But here you think about x and y as a function in terms of t. So I'm going to just write it down. So this. So if I will think about them as a function in terms of t, that means I'm going to use a chain rule when I'm going to. The first rule that you can use when you're going to differentiate this expression, the derivative of the whole expression is going to be equal to the derivative of each individual term. So let me rewrite it down. So I will have d over dt of the left-hand side is equal to d over dt of 2 minus d over dt of ln of 2 and d over dt of ln of x of t. Okay, so I think this should be clear as a first. And overall, why I start to do that, because I saw in my problem I have some expression, I have two variables that depends on some variable t, and I need to find dy over dt. So that suggests I need to use implicit differentiation. Okay, our next step is going to be going to take the derivative of each individual term. So the idea is, let me write this in the square parentheses, is the following. if I'm going to take, let's say, d over dt of my function, let's say like y of t, then that is going to be equal to just y prime of t dy over dt. Okay, it's going to be equal to dy over dt. So the idea of this expression is the following, that let me actually make it bold for you, and I will change the color to blue or red. Okay. So this tells me the way how I kind of take derivative using this notation. When I take derivative of some function which depends on t, I take derivative of outside of my function. But since my function has like different variables in t, then I will indicate that I took the derivative of y corresponding to t. So that's why whenever you see like kind of this expression, what you should write down, you should write down this. So let's do it step by step. So for this expression dt over of 2, what I'm going to have? I will need to take, according to my formula over here, 2 prime, yes? But 2 prime, as we know, is going to be equal to 0 because it's derivative of the constant. So that's why I'm going to have 0 over here. ln of 2 is a little bit tricky. ln of 2 is also a number. So here I'm also taking derivative of a number. When you take derivative of a number, that is just equal to 0. Okay, then we have 2 terms left. So what I will recommend whenever you do this problem, so it's up to you, I will do each of the term in a separate line. So for the first term, and let me do it slowly, I will need to take the prime of the inside function. So that is going to be equal to the prime of this expression. But here, we're going to use kind of the chain rule. Why are we using the chain rule? Because you can see that my function x belongs as a composition or like as a subfunction of the function ln of. So that means that my operator d over dt is going to go and be applied as a chain rule. So that's why I will take derivative of my outside function times d over dt of my inside, and of my inside is going to be x of t. And let's continue our computation. So derivative of ln of x of t is just going to be 1 over x times derivative of x of t. But derivative of x of t is going to be kind of x prime of t. Yes. And that's going to be dx over dt. So that's the result of my first computation. Let me just double check something. So we have x prime. What I'm thinking here about that we have x prime and dx over dt. So we will know that x from our formula here is going to be equal to 2. So I will know that this term is 2 on the bottom. But then my question is about these guys. So here, okay. So, okay. I see. So here, when I take d, so when I will take derivative of d, d, how to explain that? So here I'm going to be left only with dx over dt. And if you will think about when I'm going to write, and what I'm trying to do, I'm trying to explain to you to give it that as a rule. And then probably I can just change my previous rule, but I don't want to change it. dy. Let me think. Okay, I will change it in the following way. I will change it like this. So if you have d over dt of y of x, that is going to be equal to and of y prime dx over dt. This is the rule. So, and if I'm going now to explain this step here. So I'm looking for d over dt of x of t. So what I'm going to have here, I'm going to have there, write down actually here. I'm going to have there x of t, yes. So when I'm going to find the derivative, we'll have x prime, and the variable which is inside this t. So I will have dt over dt. And you can think about the dt over dt are going to cancel out. So if they're going to cancel out, I'm going to have just with x prime. But x prime is exactly is my dx over dt. Okay, perfect. So let me explain what I just did. So the rule is the following. If you have a function y in terms of x, and you know both variables are depends on t, then you take derivative of your outside function y, and then write down dx over dt, so derivative of x corresponding to t. Since in this computation was when I was doing for this term over here, I have ln of x of t, then derivative of ln is just 1 over x, which I have over here. And then I'm going to take derivative of d over dt of x of t. But according to this formula, using this computation, it is just equal to dx over dt. And here, what I can do to save my time, I can evaluate this expression right away. What I'm trying to do, okay, I will just write like this. I will evaluate this expression when I will evaluate this expression when x is equal to 2, and dx over dt is equal to 6. Yeah. So in this case, what I'm going to have 1 over 2 times 6 is equal to 3. So here, let me pause the recording so you can ask questions. So what we just did, in this expression, I'm going to put the space. We found that this term is going to be equal to 3. Let's continue computation. To finish our computation, we need to find d over dt of this term on the left. I'm going to erase that my variables depends on t to make my expression look simpler. So what do I want to do right now? I want to compute this expression over here. And this one is going to be applying the chain rule. Yes? So what I'm going to have, I will have d over dt of the first term times the second one, plus my first term times derivative of the second term. I hope that makes sense. Derivative. So this expression over here is derivative of x corresponding to t, but that is just going to be equal to dx over dt times e of y. But then derivative of this term is going to be, again, like according to my rule, derivative of e, and derivative of e is going to be just e itself. But since e depends on y, that means my operator d over dt will become d over y over dt. So that's it. This term on the left, before we go into plug in any values, is going to be equal to this. So right now what I'm going to do, I'm going to put parentheses around it. And I'm going to relate this expression when x is equal to 2, y is equal to 0, and dx over dt is equal to 6. So let's see what I'm going to get. I'm going to get 2 times e to the power of 0 plus 2 times e to the power of 0 dy over dt. And that is going to be equal to 2 plus 2 dy over dt So then what I'm going to obtain? I'm going to obtain the following, that this expression is going to be equal to, on the right-hand side, we're going to have 2 plus 2 dy over dt. And this 0 are going they're going to disappear, so we'll have 3. So that's why I'm going to have 2 dy over dt is equal to 1. So dy over dt is equal to 1/2. So someone told me the answer should be -3 over 2. So we still have over 2 stuff, so that's good. So this one might be some either arithmetic mistake. So can you please tell me, is this like -3 over 2, or they're like from the solution? Yeah, and let me stop recording right now. So I will come back and explain what's the actual final answer. So you can see that I'm a little bit dyslexic, so my mistake comes from here. That dx over dt is not equal to 2. Equal to 2. Dx over dt is equal to 6. So let me make this red. How am I even a math major? I have no idea, to be honest. Because can you imagine like to take finals math test when you do this kind of mistakes? That was a nightmare for me. So okay, so it's 6. 6 here. 6 I'm going to put over here. Then that is going to be equal to -3. So I will have -3 on top. And we got the right answer. So the answer for this problem is going to be dy over dt is equal to -3 over 2. So a short summary, what do you need to know for this kind of problems? So first of all, don't be afraid of these numbers evaluations. That means when you do the computation, you just need to plug in your values. I split problem into kind of sub-problems, just not to have like messy stuff and to track my mistakes it helps me to track my mistakes more easily. But the main formula that you need to use for this problem is this one. So whenever you take derivative corresponding to any variable of some function that depends on some variable of another variable, is going to be just the outside derivative of this function times d of that function variable corresponding to the variable, to d of the variable that you differentiate. And you treat this operator over here as a just regular taking the derivative. So that's why when I had the product of two kind of functions, of two variables, I apply the product rule, where instead of prime, you just write d over dt. Okay, let me pause. So for this problem, what we're going to do, we're going to find the indefinite integral of u over square root of u minus 1 du. So let me write that integral down. I will have integral of u over square root of u minus 1 du. So whenever you see the integral, you don't have still, we're going to learn more integration techniques in Math 16b, but right now we don't have a lot of integration techniques. One of the main techniques that you're probably going to use, especially if you look at the integral, you have no idea how to do it. The purpose of the u sub is to make the expression for your function to look simpler. The way like to figure out how to apply u sub, what you need to do, you just need to take a look at your function, just stare at it, and think and ask yourself a simple question: what I do not like about this function. So first of all, I do not like that this is a fraction. Can I do u sub to get rid of the fraction? Can I kind of make, and here like u sub is a bad word, so let's use like v sub. So can I make v sub to equal to some fraction? No, it's going to be a nightmare because then I need to take the derivative of the fraction, and I will definitely not make my expression. That's a bad idea. Okay. What else do I don't like? I don't like the square root, but I don't like the inside of the square root of u minus 1. You can definitely I think I can convince you easily that if I will have just u there, that you will like this integral way better. So what does it suggest? It suggests that I just need to make my v to be equal to u minus 1. So when v is going to be equal to u minus 1, then dv is going to be equal to derivative of the right hand side. Derivative of 1 is 0, so it's going to be derivative of u is just du. So dv is going to be equal to du. So then I'm going to rewrite my integral in the following way. So on the bottom, I'm going to have the square root of what? The square root of v. Yes, because u minus 1 is equal to v. Then my du is equal to dv. But on the top, I have u. And there's a small problem. Because whenever you're going to integrate corresponding to variable v, then you want to make sure that all your function, the whole your function, is just in terms of one variable v in this case. But from this expression over here, I can see that I can express u in terms of v. U is going to be equal to v plus 1. That's why here I'm going to write that down as v plus 1. And then this integral is going to become trivial. So let me to do it just to show you the computation. So first, as the first step, I'm going to split my fraction inside into the sum of two fractions. So what I'm going to have? I'm going to have v over square root of v plus 1 over square root of v. So I just split my fraction into the sum of two fractions. After this, I'm going to simplify my expression. So I will think about square root of v as v to the power of 1/2. Then according to the some algebra rules, I can derive this as v to the power of 1 minus 1/2. And this is going to be just v to the power of negative 1/2. And then you can see that my integral will become just v of 1/2 plus v of negative 1/2. So here then I'm going to use the power rule, and the power rule tells me that I will take my expression. So in this case, I will have, then in this case, I'm going to have v is 1/2. So I will write this down as 3/2 on the bottom. And this is going to be v plus 1 plus 1/2 plus 1, which is exactly as my. Then I will have this one plus negative 1/2 plus 1 is 1/2. So that's why I will have 1/2 over the bottom, v to the 1/2 on the top, and then plus c. But don't leave as a final answer, because what you should have, you should replace, you should have your answer in terms of u. So that's why this is double fraction. You can check that it's going to be equal to 2/3. And v, remember, v is equal to u minus 1. So you will have u minus 1 to the power of 3/2 plus 2. 1/2 is just square root. So you can write this as a square root of u minus 1. And of course, plus c. So that is going to be my final answer. I didn't see the solution, but I believe that should be. So let me pause the video. So let's talk a little bit about the meaning of the definite integral. So if I'm going to have my function y is equal to, and I will define this function on a closed interval ab. Then I want to understand the meaning of the integral between a and b of my function f of x dx. And the meaning of this integral is the following. It's going to be equal to the area under the curve y is equal to f of x between a and b. So what does it mean? It means if you have, this is your Cartesian coordinates, and let's say this is your function, and I'm going to indicate this is my a, this is my b. Then the definite integral between a and b is going to be the area. So one of the kind of examples. So one of the examples, let's do the following. Consider the function y is equal to x squared, and I have the interval 0, 2. And let's say I want to sketch the meaning of the integral and find the integral. Let's do both. So I have integral between 0 and 2 of x squared dx. So let's first sketch the function. So what I'm going to have, this is, let's say, my 1. This is 2. So when x is equal to 1, y is equal to 1. So I'm going to have this point. When x is equal to 2, y is equal to 4. So it's 2, 3, 4. So what I'm going to do, I'm going to more curvy like this. So they see, like, I cannot even sketch parabolas. Yeah, so it looks like this. So the meaning of the integral between 0 and 2 of x squared is going to be exactly this area over here. So if I want to sketch this area, I'm going to have this. And if I want to evaluate the integral, then this is, as you know, will equal to x cubed over 3 between 0 and 2, which is equal to 2 cubed over 3 minus 0 cubed over 3. Yes, which is equal to 8 over 3. So that means 8 over 3 is going to be that red area. So this is like one of those examples that you need to keep in mind. Okay, but let's say I have the following example. Let's say I have y1 which is equal to x and y2 which is equal to x squared. Then I want to find the area between those two. Okay. What is going to be super useful is to sketch them. So y is equal to x, as I know, is going to look like this. Parabola is look like this. So to find the area is going to be this region over here. But here, remember that if I will take the integral between some values, let's say a and b, of my parabola x squared dx, then that is going to be the area, which I will be indicate the blue one, under this parabola over here. Do you see? This is the blue one, which I will indicate this one here, is the area under my parabola. If I will consider the integral of x, integral between like a and b, we're going to figure out, so of x dx, then there's going to be the area under y is equal to x, which is given by kind of this green stuff. And then you can see, if you will take the green area, subtract the blue area, you exactly is going to have kind of the leftover, which is going to be the area that we're looking for, this area. So that suggests to me that the area of my region is going to be equal to the area of the function which is above minus the area of the function which is below. Or can be rewritten as like this, is going to be equal to x minus x squared, yes? Or to write it even more concisely, is going to be equal to integral of y1 minus y2. Where again, like y1 is the function on the top. So the only thing that we need to do, we need to figure out a and b. But a and b are exactly going to be the intersections here and here. So to figure out this intersection points, we just need to look at the equation. So we have y is equal to x squared, but also is y is equal to x. So I can write this like this: y is equal to x and y is equal to x squared. So from here we'll have x is equal to x squared, which gives me x minus x squared is equal to 0. But that is if I'm going to factor x, is x minus 1 is equal to 0. So I will have x is equal to 0 or 1. And that's exactly what we have over here. We have when x is equal to 0, y is going to be equal to 0. So we have this point 0, 0. Or when x is equal to 1, y is equal to 1. So, and you can just plug in, so again, like your a and b are going to be this guy. A is equal to 0, b is equal to 1. You can just plug into this integral and compute it, and you will get the area between those two curves. Okay, thank you so much for attending today. I'm going to see you next Friday. So not next Friday, this Friday. Okay, have a good night.